Hi everyone, my name is Naomi Flinchum-Marquez and I am a professional nursing tutor. I'm also a registered nurse and currently working as a school nurse at Krieger Elementary School. I was a graduate of the Duchess Nursing Program in 2023, so I'm a new nurse and I just wanted to share with all of you guys some helpful tips and tricks for how to solve um, math problems using dimensional analysis. So I'm going to view this presentation. Let me see how I do this. Here we go. View slideshow. Then that'll help me when I can use my pen. Let's try it out. Turn on the pen. Perfect. Okay, here we go. So some learning objectives for this session. By the end of the session, I hope that everyone can identify the tool of dimensional analysis, list some common med-math conversion factors, and also apply dimensional analysis to calculate some common nursing math problems. This is the best video that I found ever. This guy, he calls himself the Organic Chemistry Tutor on YouTube. You guys can find it and watch it at your own pace. We can also watch it here just in case folks don't have access to it. There we go. I had to figure out how to work my pen. Let's play it at twice the speed. Thank you guys for being patient with him being at double speed. But if anyone wants to go see the video, I highly recommend watching the entire thing. I've had to reference it many times, and I've played it at super speed, and I've also played it very slowly just to get the concept down for dimensional analysis. I think the most important thing to note is that up here, you're always wanting to get all of your units in order so that you're constantly canceling the matching units out. So you have a year up here and a year down here, you can cancel those out. You have days, you can cancel them out. And just understanding that basic concept will really help you with solving med math problems. So this video is not specific to nursing math or med math, but I found it's been the most helpful for understanding how to do dimensional analysis. Some common dosage calculation conversion factors. You'll see a lot in questions you get. The 1,000 micrograms equaling 1 milligram right here. We also have the 1,000 milliliters equaling 1 liter, and the 1 kilogram equaling 2.2 pounds. I feel like those are the most common. Sometimes you'll see them slip in the 30 milliliters equaling 1 ounce, or maybe even, let's say, 5 milliliters equaling a teaspoon. But for the most part, if you have these down, you'll be able to solve any med math problem. And the reason I wanted to put this video together as well is that I feel like oftentimes in tests, you might miss math questions where if you figure out how to solve the math, you'll never miss a math problem again. So I don't want anyone to lose points on their exams because they are unable to solve math problems. I have also here the macro drip factors, and the standard administration sets have a drip factor of 10, 12, 15, or 20 drops per milliliter. And for a micro drip set, the rate is 60 drops per milliliter. So sometimes you'll see a math question where they don't tell you what the drop factor is because it's a micro drip set. So you just need to know micro drip, 60 drops per milliliter. UWorld has been something I've used as a tool. I highly recommend it for NCLEX style questions. They also have a free trial where you can go on and just do med math. It's expensive, but it's worth it. So if you can afford it or you can pair up with someone, I highly recommend UWorld for med math and for NCLEX style questions. It is awesome. And they have really great explanations for how they solve the problems and great visuals. I could not recommend it more highly. I am not paid by them at all. I have no affiliation with UWorld other than having used it myself to pass the nursing boards and to study. I highly recommend it just for studying for exams. Okay, so let's try some problems together. And I'll try to use my pen that I'm just figuring out how to use. Just to walk through some questions live. Okay, so we have this question here. A nurse is preparing to administer Haldol 2 milligrams PO every 12 hours. The amount available is 1 milligram per tab. How many tablets should the nurse administer? So this is a pretty basic one that we're starting with, but we see that we have the order for 2 milligrams. It's not working. Hold on. Here we go. 2 milligrams by mouth. And it's available in 1 milligram per tablet. So we're going to try to figure this out by saying we have 2 milligrams. The amount available is 1 milligram per tablet. How many tablets should we administer? So here, because we lined up the milligrams here and here, all we're left with are tabs. So it looks like we do 2 times 1 over 1, which would equal 2 tabs. That's a pretty basic one, but it's fun to start out with a basic one. Okay, let's try another one. A nurse is preparing to administer Lasix, 80 milligrams daily. The amount available is furosemide or Lasix, 40 milligrams per 5 milliliters. How many milliliters should the nurse administer? And round to the nearest whole number. So here, once again, I kind of like to circle. This is how I like to do it when I'm being asked a question on an exam. I have 80 milligrams. Gotta remember to use my pen. 80 milligrams by mouth. The amount available is 40 milligrams per 5 milliliters. And then the question is asking, and it should be in milliliters, how many milliliters should the nurse administer? And we're going to round to the nearest whole number. Here we go. So let's see. We want to do 80 milligrams. We want to multiply that by what we have available. So we have 40 milligrams over 1.5 milliliters. We can cancel out our milligrams, and we're going to end up with milliliters, which is what we circled before. So we would do 80 times 5 over 40. And we still have our milliliters up there, so we'll put it up there. 80 times 5, I'm using my iPhone calculator, divided by 40 equals 10. 10. So our answer would be 10 milliliters. All right, let's do another one. So sometimes you'll see these really fancy problems set up where you see a graphic image of the drug that you're being given. And that can throw you off sometimes when you're used to seeing it just all written out. So I wanted to give you guys an example of what you might see. Given information we have, the patient has allergies to morphine. They weighed 145 pounds at admission. And the medication they are receiving is Sotalol, 1.5 milligrams per kilogram via IV one-time stat. So our question is saying the nurse is preparing to administer a one-time stat dose of IV Sotalol to a patient. How many milliliters per dose, so this is what our answer should be in, of Sotalol should the nurse administer? Round to 1 decimal place. So we're going to round to 1 decimal place. And this is the information that we're given. So this one is asking us to think about a conversion factor, because it's asking us, it's giving this information, it's saying give milligrams per kilogram, yet we're given the patient's weight in pounds. So we need to remember that conversion factor that we had on one of our first pages, which is that 2.2 pounds is equal to 1 kilogram. So we have to keep that in mind when we're solving the problem, because we know that there's something that we're missing here if we only have pounds, and this is talking about kilograms. So if we're supposed to give 1.5 milligrams per kilogram, let's try and figure out what we need to do. We know from our conversion factor over here that we have to get these kilograms into pounds, so we could try to add that in. We're going to say 1 kilogram up here is equal to 2.2 pounds. We're also going to say we know that this patient weighs 145 pounds. And we don't have to put anything on the bottom here. We can just keep going. You can put it over 1 if you want to. We also know that we're supposed to, what else do we know? Oh, our drug here. It looks like it comes in 150 milligrams per 10 milliliters, so we can't forget that. So because it's 150 milligrams, we want to put the milligrams on the bottom so that we can cancel out milligrams. And we're going to put 10 milliliters here on the top. I think that looks right. So we can cross out kilograms. We can cross out pounds. We can cross out milligrams. And then our answer is going to be in milliliters, which is what we were looking for. So we want to do 1.5 times 1 times 145 pounds times 10 over 2.2 times 150. I'm going to use my iPhone calculator again over here on the side. Let's do 1.5 times 145 times 10. That number I get on the top, 2,175 over 2.2 times 2.2 times, what did we say? 150. There's my pen. That equals 330. So now we'll type that in again. And I think it's good to not skip any steps. I know it seems kind of taxing, but it's really good to try to go through it line by line, step by step, to make sure you aren't missing anything. So I got this crazy number. It keeps going. But our answer says round to the nearest 1 decimal place. So that means I need to round here to this 1 decimal place. So my answer would be 6.6 rounded up milliliters per dose. So I'm going to put 6.6 right here. And that's our answer. So some people do the conversion of the kilograms to pounds, or the pounds to kilograms as one step, and then they do something else as another step. But I like how in dimensional analysis you can do the entire problem laid out just like this. Okay, let's do another one. Our patient is prescribed 35 milligrams of glipizide daily in 2 divided doses. How many tablets per dose of glipizide should the nurse instruct the patient to take, round to the nearest decimal place? So again, I do this crazy thing where I come over here to my problem and I circle everything that they give me. 35 milligrams in 2 doses. How many tablets per dose? And then I'm supposed to round to 1 decimal place. Okay, so I see the label also tells me that these are glipizide 5 milligram tablets. So the information I'm given is that I'm prescribed 35 milligrams. I'm not prescribed, the patient is prescribed. 35 milligrams in 2 divided doses. So I can use my conversion factor of just dividing it in half to get my dosage for one of the doses. Then I can also say, you know what, it comes in 5 milligrams per tab. And I put the milligrams on the bottom because I want these to cancel out. Milligrams, milligrams. I think I have everything I need, right? Am I missing anything? I don't think so. Okay. So my milligrams cancel out. This is just dividing the dose in half, and I'm going to end up in tabs, which it wants me to end up in tabs. So 35. And I'll put the tabs up here. Over 2 times 5 equals, I'm even going to go this far, 35 over 10. 35 divided by 10 is 3.5 tabs. So this person is really going to end up taking 3.5 times 2 tabs per day, which is 7 tabs a day. Seems like a lot of tabs. But the answer to the question they're asking is how many tablets per dose? So we're going to go with this answer, 3.5 tablets per dose of these tabs. I think sometimes too with tablet questions, 3.5 tabs sounds, I guess, reasonable to me. But if you get an answer and it's 12 tabs or 28 tabs, rethink your answer. Go back to the beginning and say, do I really picture a patient taking 25, 28 tabs? Something must be wrong with my calculation. I'll go back and see if that makes sense. 3.5 sounds like a lot to me, but maybe they're tiny tabs. Look at these tabs. Okay, next one. Here's an IV question. Your patient needs 2,000 milliliters of saline over 4 hours for a patient with deficient fluid volume. How many milliliters per hour will you set on a controller? So this one's pretty easy. It's nothing too crazy. If someone's asking you an IV question and it's on a pump, typically your answer is going to be in milliliters per hour, almost always. And that's what it's asking us, milliliters per hour. It's also making the question pretty easy because it's giving us milliliters per hour. So to set this one up, we would just say 2,000 milliliters over 4 hours. We don't even need a conversion factor because we have everything we need, milliliters per hour. So 2,000 divided by 4 is 500 milliliters per hour. Woohoo! I haven't usually seen this word too, set on a controller. Usually says on a pump. Next question. A patient is receiving 250 milliliters normal saline IV over 4 hours. Using tubing with a drip factor of 10 drops per milliliter, how many drops per minute should be delivered? Drops per minute. So my answer should be in drops per minute, sometimes written as GTTS per min. Sometimes when you get a drip factor, they'll just say the drip factor is 10, but they won't say drops per milliliter. A drip factor is always written. Drip factor is always written in drops per milliliter. And that can be kind of tricky because your answer is going to be in drops per minute, but the drip factor is always going to be in drops per milliliter. So people can get hung up on that if they don't set it up the right way. So the patient's receiving 250 milliliters over 4 hours. We know we want it to be in minutes, so we're also missing something here when we have hours. So let's put an hour here. And let's put 60 minutes because we know that there are 60 minutes in an hour. We also have this drop factor. And we have milliliters. So we have 10 drops over a milliliter. And I think that sets us up nicely because we can cancel out our milliliters. We can cancel out our hours. And now we're left with drops per minute. So we would do 250, sorry my screen's getting messy here, times 10 over 4 times 60 equals 10.41666, repeating, drops per minute. And you'll have to verify with your professor, are you going to round up? Are you going to round down with drops per minute? But let's say we'll use just regular math rules. And because this is 0.4, it's not over 0.5. So let's round down to 10 drops per minute. That's our answer because it asked us to. Did it ask us? Oh, it didn't say. But we always want to give a whole number of drops, 10 drops per minute. Some teachers will say you should give 11 drops per minute. You should always round up if there's anything extra so you don't give the patient less medication than they need. So That's a good question to ask your professor. What do they want you to do? But as long as you know what to do, you know how to solve the problem. 10 drops per minute. And I think that was our last question. So thank you for joining me here. Again, my name is Naomi. This is my first med math video using my pen and my tools, so I hope that I can improve with those tools. But thank you. You can reach me here. Oh, let me go back. This is me using my tool again. Hold on. There's my pen. Here we go. You can always email me right here, naomi.flinchum-Marquez, took off the Z off of my name, at sunyduchess.edu. I'm happy to help anytime. And let me know if you have any questions. Thank you for watching. Go DCC. Don't give up. Nursing school is hard. You guys are amazing. You rock. You're meant to be here. So keep trying and keep using all the tools that you have access to. Use your tutors. Use tools like UWorld. The Saunders review book is really awesome. So if you have any questions about extra tools you can use to be successful, let me know. Again, I'm not affiliated with anyone and making any money off of recommending products. I'm just recommending what worked for me. Thanks so much.